Thank you to our lovely sponsors this year. And we are beginning. Welcome to CyBRICS 2020 task analysis session. This is day one. And today we're joined with two of our guys, Yegor Zaitsev, aka Grok. Hey, wave your hand.
Oh, sorry. Hi.
And Alexander Menshikov, aka Nostar.
Hello, hello.
Today they will explain the challenges that they have created that got the most votes on the task analysis vote. And before we begin, well, I'd like to again congratulate now on video, so it's official. Our CyBRICS 2020 winners. First place was Corrupted Ponies from Russia, or from unknown. I don't know. Well, CTF Times says it's Russia. Definitely Zero from South Korea and Japan alliance team. SPCTF Fargate from Russia. And also honorable mentions, Reka Peak from China. Fifth place, Flat Network Society from France. Thank you all guys for taking part in CyBRICS. Once again, hope you enjoyed our challenges that we prepared for you. Hope to see you next year. And well, let's begin. I think the first task that we are planning to cover today is OTP. Let me find the task. It's CTP Easy by Alexander Menshikov, OTP. So, Alex, I'm handing it to you.
Okay, I'll start in the demonstration. And that's it. Well, thank you all for participation. It was a great fun of building these tasks for you. Well, let's start from the first task, that's OTP. In the OTP tasks, we've been given this brand new website about one-time passwords and something. Here we can see three links to the client and server binaries and to the open source server sources. So we can download it and analyze to the first time. Also, we can print something into this input and got our token invalid message. So let's investigate the server application and then switch to the client. Source in the Golang, so we can see here two actions, action register and action login. And also main function where we can see that this binary simply reads from std_in the action, username, password, and doing some stuff with MongoDB. Also, we can see that it connects to the MongoDB with admin user, admin password, and that MongoDB is listening on the local host port to 7017, like standard MongoDB port. Also, it uses database CyBRICS and collection users. Then it handles two types of actions. The first type is register, where it simply finds username and password, and if he couldn't find it, he just creates new with random OTP token. That's just like random one. And login action, which is pretty the same. Oh, that's actually login. Well, they almost the same. That's just copy paste. Register finds user and prints user exists. If this user already exists, then input it with the random token. And login just finds user with this password and sets new OTP token. So let's download the client binary with copy source link, go to our Linux desktop, let it be here in the temp folder, and w get the client library. So we can see client library. We can let it be executed and try to watch the help. The help says that it has two options, login register. So let's watch register help. It says that we can provide login with -L, password with -P, and some address. Also, we can see that the address includes 22 port. That's unusual. Why SSH port? Let's try to use random credentials for the first time with default server. And here we got some response. We can copy this personal token, and it says that we are not admin user. Let's try to log in with admin login and password, client login, -u admin and -p admin, -L. Well, it says that user not found. Maybe that's because our password is invalid. So let's try to go to our own server, as said in the help. So we can provide login user, password user, just random one, and address for this machine. This machine has like this address. You can use your own machine, for example, or buy some free VPS. So it says that public key is invalid, and in our authorized log, we can see that actually someone's trying to go with the guest user. Wow, so the username for this SSH is guest. Well, let's try to simply go to the production server with guest user, like SSH guest OTP CyBRICS CTF-SU, and we've got our message that public key is invalid. Wow, probably client has some private key inside the binary. Let's investigate if this is true. Let's find strings with strings command. Let's find big strings, more than 40 symbols in it, and just client binary. Let's see what we can find there. Many Golang strings, and finally something. We've got something that looks like private SSH key. Wow. Actually, my output is shrink for a little bit, maybe because I see this zoom green border, but I will try to copy this SSH private key. Well, yeah, it is here, and let's wow. That's not easy. Let's try again. And here it is. It was hidden by our faces and zoom. So let's copy it and paste somewhere to the key 1. Well, let's try to go to the server with these credentials. That's private key 1, that's guest, that's OTP CyBRICS 2020 CTF-SU. And that's it. Also, we need rights for this, and looks like it handles our connection. Let's try to do the same as in the binary. So we know that it waits action from us. So action is register. It waits for username, let it be here, and password, let it be here. And connection is closed. So we can connect to the SSH, but there in authorized keys is probably some binary. So, but we know that MongoDB is listening for the local host. So probably someone who placed this binary inside pre-run SSH session forgets about port forwarding. So let's try to forward localhost 27017 to the our 5000 like random port. And looks like it's forwarding, it's been forward. So let's go to our machine, watch if here is port. Yeah, it's listening. And let's go to the localhost 5000, database is CyBRICS. We know this with our source code that this is CyBRICS, and username guest, oh, sorry, admin, password admin. Wow, we're inside. Show collections, and we can read from username user database. So here is admin with his OTP password, which is not looking like OTP, but we can reuse it and get our flag. So this is it. Never forget about disabling port forwarding. Well, I can give the word to the next speaker.
Hi.
All right.
Now we will talk about hide and seek task. Let's move it here. We were given a binary. We can run it, for example. See that binary asks some password. So what usually we do, we load this binary in IDA. And in IDA, we can see such simple main function. So it does about 10, I guess, checks. And if all checks are passed, we are reading some string and doing some checks. Actually, each one of these functions is just a linear equation system. So you may solve them somehow, maybe using the tree if you are lucky, maybe using Sage. And when you solve these equations, you will get string like CyBRICS, I guess CyBRICS. Hi, this is fake flag. So let's try to pass the string into binary. CyBRICS. Hi, this is fake flag. But binary says fail to us. So there's two options. Either we solve this linear equation incorrectly, or some magic is happening here. For example, we can try to run this binary in GDB or run it using trace. Trace, hide and seek. We can see read system call. So again, I try CyBRICS. Hi, this is fake flag. And now we will see that if we are running under trace, binary will print win. So it leads us to from that we can understand that binary somehow detects debugging, and now we can examine, for example, trace output because it debugging detection method will be in somewhere here. And this string, actually, if you are running binaries under a trace for some time, should look suspicious to you. So, for example, we can do cat prod self status, and we can see that there is a trace repeat, for example, string here. But the next question, where this check is takes place. I guess we can try, for example, run it via GDB and make catch this call open non-binary. So we see that in RDI register is proc self status, so it is in this is a place where we read proc self status. So we can try to find out where we are located now, and also if we can try to search these strings in IDA, we will get nothing. I guess it's all here. So we can get this address. I use Pavilion DBG extension for the GDB actually, so I can do something like that. And we can see that this is address from binary. Also, we can do, for example, burst start. Then we can try to use entry command, which should be make breakpoint at start for us. So if, this is start. What has happened here actually? If we look at the binary using redelf, for example, delf minus r, hide and seek less, and look into sections, we can see string called pre-init array. If we Google this string, we'll find that this is a section which contains array to function pointers, which will be called from linker. That means before entry point of our ELF file. But also, if we try to find this section in IDA just here, we can see that there is no any section called pre-init array, but I guess from here we can see that actually this section was renamed to frame. And we can go here, and IDA shows that is sub 704A, which is wrong actually because of ELF relocation. If we try to load this binary, for example, in Binary Ninja or more recent IDA versions, or in Ghidra, I guess, we can see that. One moment. Now I load it. I go into this here and jump to this section. Oh, here we can see that actually value here is different from value from IDA, and this value is correct. But if we try to jump to this address, we will see that this address is located after frame, original frame section, but Binary Ninja didn't load it for us. Also, IDA didn't load it for us too. Why this happened? This is because of I modified ELF headers in such ways that there's some data in binary exist. Maybe we can try see it in RDF too, but it doesn't install. IDA. Anyway, a Linux kernel loads a file using a map system call. That means that file will be mapped with a border of page size, so 486. So we can place some data in binary after the segment end from headers, and this data actually will be loaded into memory. This trick was used, for example, in this year DEFCON quals in, I guess, some pawn challenge, where we can find suitable gadgets in sorry, in memory of running file because of such Linux elf loader behavior. So how we can examine the code placed under after our segment. For example, in Binary Ninja, I guess we can do something like that. We switch to row and just take this value and go to press F, say that this is x86, x64, operating system Linux, platform API, and we see that there's some function here. And this is actually pre-init function, which is called from dynamic linker. And all we should do now is just analyze what this code is doing. If we go here, we can. We also can try to do this in IDA, but in IDA you should load this file as a raw file, so it can be done like that. Here I choose binary file, say 64 mod, okay, and we jump here, make function here. So this is how this function is look in IDA, and then we need to analyze what does this code do. I guess I could show it in assembly. We call this function, which is read prod self status, as we can see here, and then using syscall number D, I guess, which is sig action. The handler for sig fault is setup. And then, if this function not detected debugging, we jump here and just change memory protection for first 3 pages to, I guess this is write and execute, and also we map some one page at this address 1000000, and in this memory we will save this value. Later we can see that this value is actually offset to this binary data. Now we should try. Also, this, I guess, can be done via in GDB, as I showed earlier, but step by step. But I personally more prefer to solve tasks in statical way. If we analyze this part of code, we will find that this is only for getting the code address and the binary base load address. So, and this function is taking 2 functions actually. One is signal handler, and another one is a I guess it's called SR store. So it a function which contains a system call for SIG return. Again, either on GDB or in inspection and calculation, we can find that this code is a SIG fault handler. As we can see here, this code is just here we change memory protections, and here we just XOR original page with, if we analyze what here is happened, this is a corresponding data from this binary blob, which is we see here. And for example, we can try something like that. I go to the start function. Why I go to the start function? Because of this is the entry point. So first instruction, which will be executed, is located here, and SIG fault will be generated just because of invalid memory protection. We can try. If you try to do this in GDB, we will need to patch anti-debugging code, or we can patch binary. But we can actually did it just from either console. So I just take address of start function. I just take address of binary blob, which is let's check here, and no, this value plus start offset from start of the page. So it 640. And now we can, for example, write some dirty one-liner, for example, like that: patch byte A plus E byte A plus E XOR byte blob plus E for range, I don't know, for example, 46 multiply 3. Let's try. There's something here. Here. For E in range. E in range. And if I go to start now, I can see another code which is not looking as just random trash data. I guess it would be easier to do so. I guess I can do select all, analyze code, analyze. I just rerun analyze, so I go again into start location, and now I could examine what this code is doing later. Actually, here we just check, we just print hi enter password, then we read password string, then we compare it with value CyBRICS hi. This is fake flag, and then we, if the string is matched, string with fake flag, we can try to open .real flag file, read it, and then we're using our fake flag string as a parameter to SHA-1 functions. I guess it will be here. Nope. Then probably here. As is accept. So here we create using a Linux kernel crypto API socket with type if_alg. And the second parameter didn't remember how it called correctly, which will be calculated SHA-1 hash of data which will be sent to this socket. So we we bind it, then we should call accept on this socket, and then we read SHA-1 from our fake flag string. Then we use first 16 bytes as key for IS CBC mode, also using via kernel crypto API, which could be found here. And I guess in the end here we have two functions which just compare result of encryption of our real flag file. Oh, it's not compare, it's print and win. This one for compare and this one for compare with CBCIS encryption of our real flag contents with this hard-coded data. So we could just extract this data, write simple Python script, for example, and decrypt this binary data. And we will get string, something like CyBRICS. This was elf when magic, I guess. So there was a question how this task was done. And actually, I guess I can quickly show you. First of all, I use simple Python script to generate this terrific linear equations. So this is a main C file, actually what we see in IDA. And also here I add a pre-init array section with pointer to dummy function, and IDA before, I guess, 7.5 will show incorrect value here after our modifications. Then I create a bunch of helper functions without using any libraries. Then using Raider2, I extract the body of this function using via this script. This small helper script is for creating strings on the stack. Then I have two awesome files. First is a file which just check it debugging, set up it SIG handler, set up it SIG handler, and if need, change protection flags of first 3 pages, executable pages of binary. Here is just some stupid macro, which this script Python or temple.py just run extract function py, so it will get bytes from this compiled helper function.o file and paste it here. And the program awesome is just a main logic of the binary. Here I add 640 knobs because, as I said earlier, first instruction in binary which will be executed will be at this offset from the start of the page. And then I use, I guess it will be here, this Liev script, which is pasted my simple shell, compiled simple shell code into the binary after segment, fixed header, so in such way that the Linux loader will be happy. Also, it writes some data for simple shell.awesome to find to help him find a binary base address and own load address. Here we patched in main C. You will see that there's a big my data array with such pattern. So actually, this Python script taking program, compiled program.asm file, and XORed it with corresponding binary executable pages and save in this array, just patching the binary. Here I looking for relocation for pre-init section and patch it. That's why IDA before 7.5 was fooled, because it didn't check relocations, I guess, correctly, for this case at least. And then again, this code actually is making creating gamma and write it into the binary file. And so at the end we just replaced string.preinit underscore array for string.f underscore frame, just for making just for, I don't know, for fun. What is small problem with this binary is actually that we can just attach to running binary via GDB or other debuggers. Unfortunately, I didn't find out how I can. Oh, actually, I just could read self-rots many times in binary, but it doesn't seems for me. I can't use trace me syscall here for defining for detecting debugger just because of when we call syscall trace me, the signals won't be delivered to our process, and our logic will be screwed up. So that's all, I guess. If you have some question, you can ask me, I guess, somewhere.
All right. That was quite a hard thing. I wonder if we could show all the guys, but no idea how. Maybe it doesn't work when a screen is demonstrated. Oh yeah, now it works now. Nice. Okay, that was hard. So we have we have some comments and questions from the chat. Binary says, can you write a text write-up anywhere? Like, there are many hard places to understand.
I guess I probably can release source code of all this terrific.
He is also suggesting you write an article.
Oh, I think about it actually, but I don't know. It just two simple tricks which combine together. I think that both tricks already known. I don't know. As I said
There's also a comment from Megalodon. That won't be my definition of a simple Python script. And also Binary says, yeah, source code is enough.
Okay.
Great, thank you. That was one of the most asked for challenges to explain.
I hope you learned something when solving this task.
Yeah.
Thank you for solving.
So now we will have something to like ease your brain. That will be Alexander's Web Easy GIF to PNG. Let's begin.
Well, okay, welcome back. And we'll start from the easy GIF to PNG task, which is probably we'll touch for a little bit because there are already lots of write-ups. So we've been given source code of this horrible website and the link to the website itself. Here we can upload our GIF image and get it divided to the frames. So That's it. Let's go to the source code. The source code doing some checks. Check that file is actually exists in the post request. That file has file name. That file name content type. That file name ends with GIF. That file name's content type is image GIF, and that file names is matches this regular expression, which is kind of quite primitive. We can do lots of stuff with this permit. And then if the file is allowed, it tries to somehow secure this file name, but this variable is not used. So probably due some bug. And here we can see that our file name goes to the uploads directory. Basically, our file is being saved to the upload folder, and then is being created some random directory in the upload folder, and FFmpeg is converting our GIF image to the subset of PNG images and save all of them inside this directory. So we can see this directory actually. Yeah, I can't see, but you can. That here is a result and UUID of your session. Well, so what we can do, we can see that this file name goes in subprocess without any modifications. So that's probably a shell execution. We can inject our code inside it and it will be executed. There are two main intended ways of solving this task. The first one is you can see to the bottom that our images by this URL is being delivered to you without any problems. So if you have some file in this directory, then this file will be returned to you. So practically we can execute some command with this injection, and result of this execution can be placed inside one of images in this folder, which can be downloaded without any doubts. And the second way, more beautiful way of solving this task, is to inject our code somehow to this command and won't break this command, because FFmpeg allows you to do lots of different stuff with the image. For example, it allows you to even draw text over the image. So you can draw output of your command, of your shell exec, on the image itself and then download the modified image. I will show you how this is doing. Well, with the curl command, we can actually send this file cat.gif with file name cat.gif to our production server. If we do this, we've got this result, and we can just simply place this result here and see frames of the cat image. Well, if I already prepared some stuff for you, for the first shell exec, we can do this command. So the regular expression can be overcome simply with base64 function, which can encode your special symbols with base64 code, which is allowed by our regular expression. So the first way is just cp sources or list directory, or doing what you want on the server and place results into this image. So let's make base64 of this command. You can see this, and just execute the following command. This command is simple. Let me show you. here we have our command. It is like this. And we know that our text will be placed here. So let's just take this file name and place it here. And you can see how our data is changed. So we can see that we closed cat GIF file, then we close our quote, then we do pipe, we run this base64 command, which copies file to output directory, and then we just echo.give to overcome the check that our string ends with .give. So if we run this command, we will get some result, but we know that our command actually copies the file here. So we can go strictly to the static directory and take or upload, I don't remember. Yeah, and upload this result. So let's do this by CURL, and we can see the source code of our main.py function, main.py code with a flag. So the second way of solving this task is almost the same, except that we don't copy anything anywhere. We just draw text over the image. Let me show you how to do it. Just the same shell execution. We can close our quote. Then we can read manual of FFmpeg function binary and got that we can draw text, for example, AAA over our image. And then we can add tag or do something else to close to end our line with .give. So let's do it. Everything is all right. We can copy this result and go to this URL and see that our cat actually has AAA over the image. So now we can place something instead of this AAA. For example, we can place, we can read main.py, we can grab flag from it, we can base64 it, and we can cut long lines. So just run this command and got new image, which consists of base64 flag. We can check it. Actually, that's the first 20 symbols of it, but you can modify cut function and get more of it. So, well, I don't actually. It's been closed. No, it's here. So let's see that ZM. So it starts from flag, and then you can see the flag itself. Well, this is it about GIF to PNG. Actually, there are more unintended solutions, and one of them was using DNS requests to get output from the server, because all the network was disabled by IP tables, but eventually our DNS port wasn't. So you could use DNS to pipe your data to your own server. But looks like that this is more difficult way of solution than just copy file to the output directory. Well, this is it. Looks like the next task is developer notebook, yeah? Vlad, can you hear me? So yeah, let's go strictly to the next task, which is developer's notebook. In this task, we'll be given this beautiful website, which states that it can check your design of your website free, but only for paid accounts. Well, actually, our team token from the board can allow us of using this stuff. Let's just place here something like Yandex and check how it works. Well, if we place Yandex in here, we should wait for a little bit, and then it states that Yandex web design score is 93%. So, wow, what to do next? Well, we don't know anything about this task, but we know that some experts, probably humans, probably not humans, are going to the sites provided by us because they need, obviously, to check our design. So let's create our website somewhere. For me, to be this simple server, and let's just log all the HTTP events that goes to our website. For this, I coded simple echo server on Flask. Let's investigate its source code. It is quite simple. The source code is like this. We just place default route of our website. We print all the HTTP headers. We print body post data. We print everything and just run it on our server. Then we need to provide our server URL here and get demo itmo.xyz. That's my server. For you, you can place, for example, your IP address. And then let's check and see if someone come. Well, someone came, and we can see that he came with some access control request headers and with referrer. Actually, it came from some strange website. Let's check this website. And also we can see that he's not doing anything on our website, just one GET request to the website. Let's open the address that we've got. And we can see that this is probably some kind of expert form where he can place our URL, can place score, and provide some feedback. And for now, only 2 URLs in here, but you can grab for CyBRICS and fast see something unexpected is in here. You can see that there exists a dev website. You can also make this by logic. Let's ping this dev website. And we can see that dev website is actually goes to localhost. That's strange. Probably this developer of this website is using this dev to just test this website on his own notebook, on his own laptop. So probably he has his own production or development version of this website somewhere on his notebook, on his laptop, and he used the same laptop to go to your website. So let's check something that we usually do in such tasks. Let's try to send expert to the local host and see maybe he can analyze himself. Let's wait. And Yeah, actually he could, but he could only because I recreated this virtual machine and I won't close any do any DevOps stuff. So probably during the game you will get error response. But if you know that this site, this production website is driven Nginx. Well, so for the next step, as I remember, you need to find actual port of developer's local website copy. That was not so difficult because I used not random port, but common known port 5000. There are not so many random, not so many common ports, like for Node.js, it will be 3000, for Python Flask, it will be 5000, for some popular web frameworks, it will be different. So you can just somehow brute force this port. But you will be doing this later because via this form, it is very difficult to do something like this because you have reCAPTCHA, you have some restrictions of timing. So that's not a good way of finding this port. What we can know next is that our expert has real Chrome browser. So he will execute all JavaScript on his browser. And also you can see that production version of free design feedback. As I remember, it has some course headers, which means that you can make JavaScript requests to this website from any other website. Yeah, you can see access allow origin. So our guess is that we can run some JavaScript on our website, then developer can go to our website, and we can scan ports on his local host because, of course, headers that will probably exist on the development copy of the website. If not, then that's good game and we couldn't do many stuff from the JavaScript. So let's test our luck. We can extend our Python script to provide more functions. Here you can see, oh, I have this for you. Here you can see simple script that we will place on our page. This is just fetch localhost, then get text of the page on the localhost, just HTML text, then send this data to our website as get parent, and that's it. So if we place this text on our website and the expert goes to this page, this script will be executed and we will get his localhost data to our website and log it with our application. So let's run our website and ask expert to go to the as I remember /0, which will produce this script for him. And let's check data. Wow, we have his data. We know that here is some CSS, and we can see that version of this website is development 1.0, which is different from this production version. So maybe this website is slightly different. Here we also see that placeholder contains something that refers to the SSTI vulnerability, because templates often goes along with SSTI, and that's it. Also, here is some random name which is weird. Let's try to send something using this HTML form. How to do it? Let's write another JavaScript. So for now, the JavaScript will be like that. There is localhost, there is post with application X form URL encoded, and with body with URL1, score 1, and feedback. If you know, this is URL encoded 7 multiplied by 7. Just to test if maybe there is an SSTI, you can place here hello world or something else. So let's place this script and ask expert to go to the /1. Let's wait and see output. Well, he came and something's happened. Probably the node will be saved, and we've got another random name, which is also weird. Well, let's try to see nodes of this name which was delivered to us. Let's create another JavaScript which is doing this get requests with the name that we've got, and the name was Angela Turner. So let's modify our Thomas and copy Angela Turner is here. And let's run and ask, oh, why it's not saved? To the second JavaScript, yeah, and here we can see the response. We can see 1, we can see another one, and we can see 49. It means that SSTI was executed 7 by 7, that's 49. So congratulations, now we have SSTI and we can do wherever we want. It also requires some magic to exploit SSTI, but that's kind of not a difficult task for you, because this is common known vulnerability. So after some tries, you eventually can go to something like this. That's common Python SSTI vulnerability execution, which found open function with some tries, and you can run cat on this source. So if we place this to our website and ask expert to go and exploit this SSTI, we can see that he's got another name. Oh, actually, on the server, I hard-coded by number 3 the name, which is 0, which is 1. The name, can see the name is here, feedback, and well, probably we need to decode this. Just lack of login. Let's decode it, and we can see that the name which we've got is actually 0. Okay, let it be 0. Probably that's because my exploit differs from standard way of yeah, I just used one for getting for the name of person. So now we can go to /2, but instead of Angela Turner, we can use this one. And probably after going to the /2, we will get our source code, and you can see the flag, which is here. Well, that's it. Quite a long way of exploitation, but the whole idea is to get localhost, exposed software on the localhost via JavaScript. So that's an idea. Well, that's it. That's all. I can stop it.
All right, thank you. So next one will be Yegor again. And by the way, we have a question from Binary about the previous task. Quick question: was the task about hide and seek and hiding control flow in ELF a task from real life? Was it some case of malware analysis?
No, I think. At least while I doing Nix-based malware analysis, I didn't meet anything harder than just copy of public bots, simple bots. So I know maybe somebody used it, but he didn't catch it. Maybe. I just see. Oh, sorry. I just see the map technique from DevCon, as I said earlier, in Pwn challenge, where you just could use some data from raw data, I guess, section in order to complete your ROP chain. So this is a map trick, and pre-init array. I just someday started to think, is any way to execute my code before start function, actually. Something like that, I guess, TLS entries in PE files, maybe.
Okay. Sanya, there's a question from Binary again. How does fetch function make the site follow localhost? Do you understand the question?
Yeah. Actually, the browser allows of doing this. Our question is why this website is. Well, I see you mean course headers, because by analyzing our production website prod.free-design-feedback, you can see that it uses course headers. Course headers is something that can allow browser to make cross-domain requests. This is commonly used during testing of your web software, where you have your development copy of the application and you need to do requests from different domains, from localhost, from some production domain, from development domain, and so on. You just use course header and that's it. Also, course headers are used for production APIs and so on. So browser just doing request, checks that header course is allowed you to go to this website and allows JavaScript to make requests to this. So localhost or other host, that's all is allowed by the web browser.
And also following the location to localhost is allowed, right? Following
Yes,
the
that's allowed.
redirect. Okay. So
I also know that there was some scandals in media when some common websites trying to use your local host and trying to find the open ports on your local host.
oh
So
yeah,
this
that's
is a
anti-fraud.
real life thing. Yeah.
Okay. Next one, we invite Igor for some, again, brain stretch, which is baby ref.
Okay, let's start. So we were given a simple XML file, and also we have a link to site which can be used to run and execute this XML file. So you can just use web version, or you can download offline version. Like me, I guess this is just one HTML file on my file system. What we should do is just open XML file in here, and then we could try to run it. Actually, to run snapcode, we could to run exactly this snapcode. I understand later what has happened. We can just press the flag here and press space, so we can see some animation, and we will see the log which is asking for some key. How we could understand these visual coding languages? So we have some switches here, which is blocks grouped by the purpose. So for example, here we have some control blocks. Here we have blocks which are using to doing some movement with our sprite. This one responsible for sound, and so on. So as we can see here, I have block when the flag is clicked, set k to nothing, say is run to 0, say nothing, hide, switch to costume logo. Actually, here we can see the costumes tab, where we can see that there exist 3 costumes for this sprite, and also there exist 7 sprites different. But all other sprites, if you look at their code, they are rather simple. So they just needed for initial animation. The main logic is happened here. So when I receive start crack me event, each of these blocks are separate and can be executed in parallel. So for example, actually in Snap, we can send one event to 2 different group of blocks, and they will be executed simultaneously. Let's try to fix block here. Here we can see block ask same as a k and wait, set k to answer, set k to list, set test to list. So we create test variable, which is actually list. Then we just go into our k input, k string. This is answer variable, is actually contains data which we will write here. Then we compare lengths and checked for equalness of our input XOR 33. This is JavaScript function which is actually just XOR the I guess it's Unicode number of some letter from our k and 33 int. How we can solve it? We can one way we can just extract all these values from here, but in reverse order because of all, as we can see here, each integer is added at the head of the list. Or we can try to modify this basic block for something like that. We can get length of, I guess, secret. Here we should take item I of secret, and looks like here we could just add a new block with say hello for 1 hour, and here we insert our sort values into test variable test list, so we should say test actually, so we can run only one group of blocks just clicking on them. So I write something here and got length of, I think the secret is missed. So again, and we can see that also we can see the values of secret. And here we should paste some blocks which will be convert this list to string. Length of secret to last. Why we can also test. For E from on to length of secret. That's strange. Well, maybe just extraction ints from here will be easier. Trying to solve this task, I guess, 3 times this way, and each time I need some time to figure out combination of these blocks. But I think that that's rather easy task anyway. Maybe there's some question about incident task. Oh, sorry, incident task will be next, about the baby ref task. Okay, so let's move to incident task. If we see the description of incident task, we can read here that we are given SSH to some server, and we are asked to find out what has happened with some password storage service in it, and there's owner of the server thinks that they are backdoored. Also, there was a hint about the middle of the CTF that service is actually vulnerable, and backdoor was installed via exploitation. And if you want to dump backdoor, you should exploit this vulnerability. So we could firstly just connect this host and see what's going on here. First of all, we could just check that something actually ran. So we can see that there is a service with PID 8. What we could do next, we could try to read PID memory mappings /prods/8/maps. Oh, I forgot to cut, of course. If we look at this maps output, we can find something strange that there exists this one mapping which is looked suspicious, and also there's two memory mappings with rebyC memory protection flags. So what we could do next, we should somehow download the service from the server. I see from logs that somebody used, for example, base64 command, but actually you are root and you can do something like that, apt install sage, and for example, SCP this file to your server. Anyway, now we have the file, so let's load it in IDA and start analyzing. In main function, we can see that some code to set up the threaded TCP server. There's a pthread routine, which is called function called logic. So it seems that logic is actually entry point of a meaningful functionality of the service. Maybe it's called business logic. I don't know. And now we can see that there is a menu which allows us to register and log in and exit. Let's look like at a register handler, for example. We will be asked for username. Then we prepare a folder for storing the user's data. Then we call function readN. And if we carefully read this function, we can see that there is no bounds checking here. So we passed here, for example, buffer with a max size of 256, but in this function we can write a much more data. So readN function is not very secured, and in every place where it is used, we have a overflow vulnerability. For example, we can see in login handler too that there's exists readN function. Also, we can see that. Oh, sorry, my neighbors just love to making holes. There's no stack cookie checking, so we have a simple stack buffer overflow vulnerability. And also, because of this is after all forensics challenge, the binary was binary, so it should be rather easy to exploit it. Oh, also I didn't show you that that we can just read the /prot/8/mem of this file, of this process. So we can try, for example, cat prot8mem. You will have a permission denied error. And even the fact that we are root didn't help us. This happened because the Docker for this challenge is spawned without copy-trace flag. Copy-trace, I guess, capability installed. So how we will exploit this? I just show you how the evil exploit was working because of in order to make your shell code, which can be used to dump memory and extract this one evil code, you just need to change the last step with actually assembly code. So there's three simple helpers, one for registering user, one for login user. Here we extracted some gadgets, and I used called CSU techniques. Some papers can be found in the internet describing this technique. main idea that we have in binary this code, and we have this code in every binary because it's just some GCC stuff. So we can first jump here and pop RBX, RBB, R12, all these registers, and then we will jump here, and this primitive will allow us to call some function if we have a pointer to this function somewhere in the memory. Because of here we use R15, R14, R14, R13, R12, and RBX, and all these registers can be filled using this gadget. So how I can find these gadgets, for example, via rob gadget tool. I don't think it installed in my Docker, but actually you can try to install it. Or you can install Roper, for example. This is another tool for finding rob gadgets. Let's try Roper. File service, and Roper find a bunch of gadgets for us, but actually not all are useful for us. So my idea was just libc address, so I just can find another set of gadgets in libc and use them. Actually, this step is not unneeded when you solving this challenge, because of by legend the evil exploit didn't have access to /prot/pid/maps file, but when you are solving this challenge, you can see all the address here, so you can just take the address from, for example, libc from here, I guess, and skip this step. Second step is constructing RBX memory for writing our awesome shellcode here. So it does called malloc with size 8000. Then it prepare arguments for mprotect system libc function. So we allocate 2 pages, make them RBX, and then using I guess again rec function, we could just read our shellcode. What could be a problem here is that FID number. In my exploit, this FID number is hard-coded because of it running actually as the first client for this service by challenge deploy logic. But again, because of we are living in Docker, we can just, for example, do something like that. And so we could suppose that the 5th FID will be for our next connect, or maybe 7. So we could try this, or either 5 or 7. And then I just read some code and jump to it. So again, we have some code writing in assembly, and actually, if you will dump this RBX memory. Oh, actually, how we can check that these memory mappings are suspicious? We can just run this. I already run this service in my Docker, so I could do something like that. Service /maps. So as we can see here, there's no mapping with 1.0.0.0, and there's no any RBX mappings. And okay, so we could dump this one. Oh, sorry, this is from my Docker. You could dump this one and this one. And trying to examine the code. Actually, I guess this one is more helpful because it have a bigger size. So actually, in this memory segment, this code will be located. So it have some comments from me. First of all, I've allocated new stack. This is why the mapping with 1 exists. Then I init this stack frame. R40, if we see at my rock chain, will be stored libc base, and RIX is contains the address of this shellcode. So then we create socket, we connect to CNC with some IP and port hard-coded here. Actually, I don't know, one or maybe more, some teams was able to extract CNC IP address just by installing T-Shark, I guess, or TCP dump, something like that in Docker, and trying to speak with service. And then you will see the outcoming packets from your Docker to this host. So here we connect to CNC. We receive seed. Actually, without comments, when you analyze this code, you don't have comments. So we read here some 4 bytes in RBP -32, and then we call function with same body. So we just save 4 bytes, which is coming from our CNC to known memory location, and then we 4 times call rand function, which is actually just simple code from libc random implementation of type 0. Actually, now libc by default using another generator, but here I use this one. So then we generate 16 random bytes, I guess, and sell 12 of them to the CNC server. And then we will read some string here. And again, we can dump the contents of this memory when we are executing our shellcode, and this memory will be contained string with a form of something like ID and 8 decimal digits. And then another interesting code is the actually backdoor installing. So this code allocates another mapping. Then we load address of this function, and we will write at this address of binary at function called enc. This is actually jump to our new executed code, or new sorry, new allocated code here. Oh no, sorry, I just a bit made a mistake. This part is copying this send enc data function into our allocated memory, and then it insert jump back to this instruction. Move RBP -304 Crcrcr register, and then we'll patch the original code. So we are calling mmap and protect here to change permission of page to rebyC. Then we patched the first instruction of this function to jump to our backdoor code, and then we make the mappings again, I guess, read and executable, and then just sleep to not crashing the program. So the thread which are infected just will be sleep for 1 hour, and then it will crash actually because of this thread, I guess. So what send enc data is doing is just connected to the same IP but different port and send the arguments of enc function. If we doing a bit reverse of where enc function and why is this function is used, this function is actually used to encrypt your password ID and your password, which you are trying to save to the server. So actually, full logic of binary is looking something like that. We are registered, we are login, then we asked for our secret phrase, which is actually using as a key for password stored in hard drive of our server. So the password stored encrypted with the key, and this key are known only by password owner. But in our backdoor, we just hooked enc function and dumped all data to CNC before the before the encryption is done. So next step was just port scan of this CNC. I guess we can try to extract address. One moment. Let's 22. 5. Oh. Maybe something like net atom. Net function. Okay, I do it by hand. So I guess the IP of our CNC is 34, 77, 100, 1000, then we should do a maps. Oh, actually, fish is showing me that I already connected to this IP address and port 12345. This port can be found via, for example, a map scanning. And when we are connected, we can see that CNC asked us for bot ID, which can be extracted from the memory dump. And then, oh, there's no such ID, but if, oh, I guess, without dumping, I don't know the ID, but actually then it will be asked for password. And password, this is this string which is generated using a random function. And actually, because of we can again read the memory, we can extract last four bytes of this password, which is, as I think, unused. Maybe not, and just revert this rand function. For example, this can be done in such rather simple script. This is a value from the CNC from one of the files, so I just use only the value which will be stored in a backdoor memory. So, and I will be able to recover another 4 bytes, and so using this password we could connect to CNC and just read a flag, something like that. I guess that's all.
All right. Nice. Okay, so next we are back with Alexander, I guess. Oh, and before Alexander shows us his task, we have a question. Um, it's a side question. Streaker asks, do you guys prefer Windows for CTFs or just for explaining?
I use well, I do in reverse engineering a lot, and for example, IDA and some other tools, and also I doing sometimes reverse of Windows binaries. So I have a VSL in Windows, so it suits up for me. So I use Windows every day, and very happy after Mac OS X actually. A bit holy war.
Yeah, binary says the same thing. Windows plus WSL plus Kali VM for all needs. Yeah, I agree with that. Yeah, I use the same setup. Windows, WSL, Kali VM. And I know Alex uses Mac. Actually, I have seen really many people using Mac OS for hacking security research and CTFs. Anyway, we are ready for the next challenge. Cyber Medium Encrypted FS.
Well, okay, finally, Encrypted FS. So we have this website where we can write secret message, save it, and get it by probably some kind of token. So let's save some random message. We will get its unique ID and not found. That's unexpected. That should warn us that something's wrong. So let's make another message and we get this message. Wow, so something's strange with this site. Also, we've been given admin token. Well, I actually think I have it to demonstrate you. Well, yeah, this is it. So, and if we use this token, it will be forbidden. So also we have source codes of this application and we can run it on our laptop. So let's, well, this is an exploit. So we have some kind of Flask web application where we have two functions, our main web page and our application route, which allows us to get secret message. So we can see that it actually renders index.html template and performs some cryptographic stuff with generating something which is random and saving to the static directory. And also when we use get function, we can see that it gets file ID from our request, checks if this file ID matches this regular expression, and admin not in file ID. So probably that's why we can't strictly get information from admin token. And then it extracts encrypted data. So let's run this on our computer and see how it works. Also, we have that we know that there is a secret key which length in is 12, which is probably random, and we don't have any way of knowing which this secret key. And we have XOR function, which simply XORing to binary strings which is each other. So let's run this website on our computer and see what happens with messages. So let's go to to this. Here we can see this web page. We can place something like test in here and see what is going on. So we can see that message is test. We can see that that there is some random RB init data, which length is 12, and this data was encoded by base 64 and placed into our cookie session with flash function. So lately it will be shown us with a kind of message and placed probably in this input. So then, so we know that we know this variable, which is random, and we can't control this. Then in RB variable, here is our secret key, which is unknown, and our value, which is known. You know that something's fixed, which is XORed to something's which is randomly distributed, will be randomly distributed. So we can't probably know this value. Then it is base 64 encoded. You can see this value. And then it tries to open this file with this name for writing and write message in it. If you know Linux, you know that there is easy to touch file to the directory, just touch it. But if in this file is slash, then you will be given error message because this open function will be thinking that this is a directory name, and directory of this name is not existent. So every RB64, which includes slash, won't be providing any written messages. So when we get for this file, we won't have anything, and we will get an error. It will be each time when the slash will be in random data. In random data, which we know, XORed to some static value, which we don't know. And also here is a trick that if it starts with slash, actually it will be saved. So it is a file. So the first byte can be slash, but other bytes can't be. So that's like a kind of padding oracle. We know lots of values, and we can send many requests to our server. And each time when something will be missing, when the document won't be created, we know that our random value XORed to our static value has slash in it. So we can rerun this application and I try to comment the probable solution. So the idea of the solution is simple. We go to the site, we get our token from the HTML output, then we try to extract this file with requests, and if this file is not found, so there probably a slash. If this file was found, then this is guaranteed that in this file name is no slashes at all. So we know that these values are randomly distributed. So if we send many requests, then each of 64 bytes on each of the index will be presented. All of them will be presented with high probability, except 1 slash. So we can collect statistics for each 6 bits, and only 1 bit will be missed, and this bit will be slash XORed to secret data. So let's collect the statistics by sending 1,000 requests, and it will take some time to get the output. And while it goes, I can comment you what's going on further. Well, so here we can see missed requests, but never mind. Finally, you will get something like this. For each of 6 bits, there will be only 1 missing value. And you know that this missing value XORed to slash will be actually 6 bits of the secret key, except 1 first value. We know this because first 6 bits can represent slash and base 64 encoding. So these 6 bits should be brute forced because we don't know its actual value. I know that this is 4. You can just make some requests and get this value, 64 requests. Well, then these bits can be transferred, can be just joined together, form bytes. The bytes can be XORed to our admin value, which we need, and this will produce actually secret token, which represents file name of this admin file. And we know that, yeah, it was found. You can see that actually this is secret value, which is represented by these 6 bits groups, XORed to admin's public value, which we know from the task description. So what we have to do is to download this file. Fortunately, we can do this because all the files are written to the static directory, which is by default exposed in Flask framework. So we can just go to the static page and get this file with flag. So that's it. I will probably publish this solution, and you can manually check why this is 6 bits, why this is 8 bits, and so on. Well,
alrighty. Have you told that the first character should be brute forced?
Yes, of course.
Oh, okay. Because I think I saw your script just output the correct value.
No, there was empty set.
Ah, okay.
I just added 4, which is right value in here manually.
Ah, okay. Yeah, okay. Alrighty, thank you. So if you have questions, please write them in YouTube chat. We are not done. Oh, by the way, I wanted to say that this challenge, Encrypted FS, is inspired by Tasteless CTF 2019 challenge BabyPad, which leaked probably the same does it have this character or does not, so by exploiting strlen, which checks for 0 byte, and not doing base 64 encoding. So go check it out. Our inspiration for this shell. And the next one will be Yegor with reverse easy polyglot.
Hi again. So let's see how we could solve this one. So in the beginning,
We'll try to solve some sound problems.
Hello? Так получится?
Да, вообще отлично.
Огонь. Надеюсь, они не сядут. So, in this task, we were given, I guess, one C file. Oh, we have actually the archive with, okay, let's go here. So let's extract them. Oh, baby ref, my bad. It's not baby ref, it's Polyglot. Okay, as I said earlier, this is a one code C file. So let's examine it. C. There's a big array with some values here, but the main function is rather easy. It just checked the environment variable xk with value modi rod exclamation mark, and if it equals this value, this program just doing some decryption stuff or decoding stuff, I guess, and puts some string to us. So let's try to run it. GCC -1 coded.c. So let's I try to evade loading this big. Okay, so we should just do xk equals this value and run our step 1, I guess, challenge. So it's some string. Let's write it into some file, for example, code.cpp, and now we will look at why I called it CPPs. For example, this is std colon cout stuff is tells us that this is probably a C++ code. So okay, and here we will see some templates, and according to this code, this program doesn't check anything. It just print for us some data. So let's try to compile it, and we will see error that template instantiation depth excludes maximum of 900. We can try to increase this limit by passing this flag, but it won't be enough. And at some value, it just started receiving segmentation faults. Maybe it depends on memory. Okay. So even 19,000 not enough. Let's add another 0 and segmentation fault. So what we should do now, we should examine these templates and just rewrite code to avoid this template instantiation stuff. So I return to my old folder with file without wrong like agents. So there's only two type of templates here exist, and actually there's some write-up of task from, I guess, CCC maybe from some years that if you see C++ templates, you can just rewrite this code to Haskell and it will be easier to read. But I don't think how true this statement is. But now let's just analyze what is happened here. So we are called template T1 with two parameters A and B, and value is equal to B plus again a value of this template, but with parameters as A minus 1 and B. And also there's a something like a guard. I can call this, I guess. So if the A is 0, then the value is 0, 2. So if we think a bit, we could understand that T1 is actually just a multiplication. So if we do, I guess we could verify this by such simple code like T1 3 4 I don't know 7 value yesterday and plus code minus source. So let's run it and we'll see 28, which is actually 4 multiply 7. And if you analyze another one template, it look a bit more scary maybe, but actually using same technique we can deduce that this is actually just addition. So what we should do now is just accurately replace this decode string with template instantiation stuff to decode with second parameter as just one value. This is I think not very interesting process. For example, you can just copy and paste this string into Notepad, break by commas, and then just make a replacement from this one from bottom to up. I don't know, is it? So first of all, we replace this one to 12, then this one for 112, this one replaced for 33, this one replaced for 77, and so on. Then you will go just one number and you delete all this long line. Paste a number here, for example, and the program will print you following code. And this is actually the last step of this challenge. It's called code.py. Python file which is rated for Python 3.8, and this is important because of I guess in some older Python, for example 3.6 or even 3.7, one of these arguments for code type is unneeded, so it just will throw an error for you. And then we can see that according to name define func, there's created 5 functions here. And if we again read this function, looking or reading online documentation, for example, of Python for code type, we can see that this is actually number of arguments, number of local variables. This is a byte string with a function bytecode, and this is, I guess, constants of this function and global name of the global object which is used. So, for example, this function f2 is using OR function inside. This function using input inside. And also we have a big function f5. How we can find out what this old function is doing? We can either trying to one moment disassemble these function bodies using Python this model. Import this B. So, and then we could try to analyze this function, but there's another way exist. We could, for example, take this function f1, named it underscore f1, and then define another function called f1 with 2 arguments, as we can understand from this value and the documentation to code type AB, print AB, and then we call our underscore f1 function. So we could do this for all functions. Let's do it quickly. A print A return underscore f2. F3 is actually obviously just reading the flag string, so I didn't hook it. And this big function is used to this big. I want to hook this big function, but I try to hook this inner function. So, for example, I could do something like that: underscore len equals len def len a print trying to get a and return underscore len a. Let's try run this code. Python 3.8 code py. And I can see here following. First of all, we are trying to get length of our input function, and then we are trying to get input of this big list. So what we could think now, this is that we should provide a string with a length equals to length of this list. So let's calculate length of this list. 48. So I generate string with 48 A letters and try to pass the string of 49 A letters. And here we can see that there is some calls of our functions, but actually we could, I guess we could just take this list and do something like that. Map x or x in this big list. Oh, my mistake. Why am I using map here? I should do just okay. And then let's join it. So we will get a string with a flag. Actually, during the CTF, I was rather frequently asking about does this one is a flag, but no, you can try it just converting these values to string and pass it to the Python code, and it will say no to you. Okay, and the last challenge I will talk about today is a Crcrcr challenge. So let's look at it. In this challenge, you are given this code of some web application. Code is rather little and simple, so we can call get files page, send some data to it in this to this form, and then our handler just create a random folder, goes to this folder, and then write your input to input file and run Encrypted.py Python script with a flag.png as argument png and input as a stdin for this script. What is noticeable here, and I guess should immediately to force you think about core dumps, is this string. If we, for example, Google this string, this means that a core dump filter contains bits, and if some bit and each bit contains two type of the mappings which should be included into a core dump. Let's finish with this one script. So then we taken all files in this one random directory and then encrypted all these files with IRC4. And if we can see here that RCK is actually constant, and this we will use this later. Okay, and also we have another route which allows you to get this file from the server. So now let's look at a encrypted.py file. Here we can see simple RC4 implementation, and then we see that program is generated random RC4K, created cipher instance with this K. Then it open a file which is passed as first argument. This is a flag.png in our case, and then saved it to res2.bin. Then we delete the original data of our picture. Well, hopefully delete, and create some random lists with size of 286. They are created just for make one of the last steps of solving this task a bit more interesting. And then input from our file is passed to a state.literal function, which is supposed to return to us Python dictionary with two fields to encrypt. This is a value which we need to encrypt, and sorry, integer value need enc, which is used to determine do we need to encrypt data with this cipher or not. Actually, there's a big typo here, and this could also guide you to think that only this one branch is needed to you in order to solve the task. So our idea now is follows. We should create core dump file. This is why we could think about it. Then we should leak some ciphertext gamma from the server. How, in order to decrypt our core dump file and our encrypted rc2.bin file. How we can do this? Actually, using this functionality. If we just say send a string with form of, one moment. In such forms, the server will create file with Crcrcr.py will be create user.enc file with I guess 4 million A letters, and then Flask handler here will encrypt these 4 million A letters with the RC4 gamma, so we can successfully revert this step of application logic. And how we could force Python to fall in core dump. Actually, we can just using Google find example of that literal eval with arguments as 1 million opened and closing bracket will crash Python with some memory error. We can verify that this is actual behavior. So I guess import ast a equals tick multiply. Okay, let's try million as in original. Now we could do st.literal eval a, and Python is crashed with segfault. Actually, by doing some experiments, I find out, for example, that millions is too big, and we can just use 250,000 of these brackets. And why we want to minimize the number of these brackets? That's because of smaller our input will lead to smaller core dump file, actually, because of if I do this, core dump will be about 30 megabytes. But when people who trying to solve this task sent 1 million brackets, they got a core file with size about 70 megabytes. And also there's a what can be a bit frustrating is that I guess at least me, when I writing the solver for this task, I don't use the A letters. I use this pattern, and actually only when I see the in logs core file of 70 megabyte size, I try to extract 70 megabyte of gamma, and only after several unsuccessful tries, I understand that this is a really bad way to extract gamma, because of we are sending not, for example, in this case, 4 million, but actually 16 million characters to server. So when we do A, we decrease our uploading data to server by 4 times. So let's run my script called solverpy. Oh, sorry. I installed one extension to Fish, which works very bad when the and folder where Git exists. So Python. Okay, пойдет. Now let's wait a bit, and here we can upload the core file. I didn't remember the site. Okay, let's do it by site. Go here. 36 megabytes core file. Boom. Boom. Okay, let's save it here. And also I should save this file, because of core file will be contain RC state of cipher, which is used to get exactly this file. And then I will also download my user.enc file with RC4 gamma XORed with A letter. Oh, it's too low. Let's add another 0 and rerun script. Okay, now just should waiting for our gamma. And and here it is. Okay, 38 megabytes. It will be enough for us. Let's call it game. Then I have simple enc.py script which takes 2 files as arguments and just sort them together and with a letter. So now I should do this with core file and gamma file. I guess gamma file saved here. Oh, core file should be here. So, okay, now I'll fix this. Bash, not lagging actually. So I go here and run Python rotate up web enc.py core gamma. Let's wait some time while it successfully exports these two files. Now we will move to our resulting out one file to core.bin, and also we will make decryption of res.2bin gamma enc file and move out one as enc.png. Well, the next step is extracting RC4 state from core file. Actually, after some time from CTF starts, we are making a hint how you can find out the layout of Python memory objects, or memory layout of Python objects. Actually, this is exactly the same way, which is I used while making this task to verify that extracting these states from core dump won't be a too hard problem. So I guess we can even just try to show how this is supposed to be done. Python 3.8 a equals b Crcrcr. Okay, let's think maybe then I need to, I'm not in Max. Let's run Max. Python 3.8. Sorry. Oh, okay. A equals b Crcrcr. I didn't 1, 2, 3. And now let's say try bash key. Okay, yes, aux career Python. Okay, I think we should call gcore with argument as, oh, I can do this in Docker. Oh, stop, but I'm not in Docker. Okay, yeah, I should do sudo. Now we will wait some time while this core file is generated, add and run another IDA, and we'll load resulting file unit. I guess it will be called as Windows core. And load it into IDA. Actually, I use IDA to examine these dumps. Don't know why. Maybe because I do a lot of reversing, so it's simple for me just using IDA for doing everything. It's even have a Python console. So let's wait while all string from this dump will be generating. I guess I should disable analysis actually to increase speed of finding strings. Oh, okay, so let's try to find our Crcrcr string. So let's try. What I wanted to do now is find pointers to this string. This can be done, for example, if we wanted to do it by hand using the Alt+B key. So we just paste the value here. We could also make check with find all occurrences and see that there's no pointer to this string. So let's try to find another one. Actually, it's strange. Oh, but maybe we also may examine the memory near our string, and we can, after some walking via memory, we can find. One moment, I will show. It's really process of several minutes. This string is totally not okay. Quick. Oh, no. Okay, maybe this one. Well, another way to, but this is actually very strange. Let's multiply 124 and make another dump. Okay, open. So now I disable the auto analysis because it not need it for me. Now we will try to find a big string with a lot of A's. And well, actually, this is looks very similar to our previous pattern with Crcrcr, where some data, maybe this is a hash of this string, I don't know, but we could try to find pointers to this. This is not very helpful for us, but actually my idea was that there should be some pointer near this location. So I guess I found something interesting. 400 is actually the size of my string which I was creating. So let's try to now again look for our Crcrcr string. Here we see our string. Here we here we see again something which is look like maybe hash, I don't know, and then 12 in hexadecimal, which is 1, 2, 3. No. Yes, which is actually equals to the size of this string. So at least now we may make an hypothesis that all Python byte let's see how it's called correctly. I guess byte string bytes are stored with pattern with size, some data which could be a hash, for example, and then string. So let's try to see some data around our string. So make data fail because we see offset to something, and that's the most interesting part here. Actually, this is a offset to string with contents of bytes, and when we call type here, we see that there's a bytes too. And also we have some interesting and if we repeat same steps, we can see that there's a type string. And if we'll try to find references to this memory, one moment, we will see that there's a bunch such reference exists. So we may made another hypothesis that the all Python types will be all Python types will be contains pointer to this to this one structure. So it's maybe looks a bit similar, for example, how Delphi RTTI is working, where the all objects have pointer to parent object. And again, for example, name year. So now what we could try to do here, we could try to find out the type, sorry, the type structure header, type, I don't know how it's called correctly in Python sources, because of I just using only the IDs which I was said before. So let's try to find out the pointer to this thing. Actually, there's no such pointers. Or we can try, for example, maybe we can find some interesting strings here. For example, need enc. Why not? There's only one such location where need enc exists, and again we are trying to examine memory near this string. So we go here and we successfully, I guess, find the, I press Alt to make quart and offset. So this one will be yep, type description. So also I create, in order to made as the process a bit easier, simple IDA script, which is actually rather stupid. First function which we will use is just find all memory location which is pointed to this one memory, and will print the name of these types. So we will look all types exist in binary, hopefully all type. Sorry, find not binary but types. And now we will see following output, and here we should look for, I guess, list. Yep. And there's another function exist. It's a bit more complicated. First of all, it's trying to find all references to this memory object, actually to this one, because of object starts from ID or something like that. Then I checked that address is located in some high memory segments. So for example, if we have values from here, which is I think just a Python executable segments, there's a very low chance that our RC4 state will be located here. So it's for just minimizing different false positives. Then Again, we can try to find out how the size of the list is stored in memory. And let's go here. Actually, it's not a list. Let's go here. It looks like it's not a list too. Not it's the list. So as I can see here, the size of the list should be placed in after 8 bytes of our list. So, oh, this is a list size, and this possibly will be list elements. This function just wrapper of standard either find binary function. So here I try to find all lists with a size, which is passed as parameter, and here I try to extract all lists values and check that actually all bytes in this list are unique, because that's how RC4 state looks like. So let's try to run my function, call it, I guess, dump lists, pass this pointer as argument. Oh, size, I forgot the size. And RC4 state is 226 bytes. So here's the output of my script, and we can verify that size is equal 18. So, for example, here will be pointers to list elements. That's why here I taking pointer from offset 16 from the start of the list, and then I just collecting all values from this list. As you can see, actually there's some false positives, but it's not very crucial for us. And the script is printed only one such list. So now we just take, for example, here my revert state Python script. Actually, there's a bunch of good ideas was in the Telegram channel how this step could be done, because of I just brute forced all possible 256 values of Y. Because of X, I know because of it's the size of our encrypted PNG file. But you can read in the Telegram chat that we can remove brute force because of we know last byte of PNG file, clean text PNG file, or there was another good solution where the author extracted from the core dump, as if I understand correctly, X and Y. So now just I just should run. Just should run my script, which is yeah, here. Now we should run Python Okay. Continue. Try. Item state web word state and file I guess called enc.png. And now we should wait when here it's not okay. This is an old file actually because of there's not time on my computer now, but I guess we should just wait. I guess now I can answer for some question if any exists.
Yep. If you have any questions, please ask in the YouTube chat.
Oh, this is not this folder.
Currently, we have none. The questions, by the way, aren't necessarily about the challenges that we
Yes,
that we explained today. Does it run for a long time?
not very. Oop. And here's a picture
Nice.
with luck.
Yay. So
Success.
that was dumping memory through core dump and RC4. How is it called? RC4 rewinding or something. Great. So let's call it a day. I think that's all that we have prepared for you today. Those are all the challenges that we wanted to explain today. And if you got any questions and didn't have time to ask them on the YouTube chat, join Telegram, CyBRICS. We're all there. Let's discuss everything that you have on your mind. And I think that's all. Thank you, guys. And thank you for watching. Bye-bye.
Bye.
Thank you. Bye.
Bye.